Hey guys, so today, um, we're back. Hey. So today, I don't know how to zoom in on this. Okay, there you go. Just, we're gonna learn the immune system. So our immune system defends our body from infections. Um, what is so unique about our immune system is it can learn. It can learn that when new infections or disease come in, it learns how to fight that. So we have innate immunity. Alexa, lower the volume. Alexa, lower the volume. Holy crap. It has innate immunity, which is the first line of defense. It's just innate immunity is immunity that just gives out the fighter cells without really thinking. Just get out there, just fight. And adaptive immunity is immunity that, like I said, it develops over time. So fancy stuff. If I do say so myself. So then we got system cells. Oh my god, sorry. I'm actually sorry. So these system cells are these are what's fighting. This is our army right here. All of this helps us stay alive. So we're gonna start with innate immunity. Like I said, innate immunity is immunity that just these are being thrown out there. So if you can tell, these innate immunity cells end with fill. They end with like PHILS. This is really important because now we know that these are white blood cells. That's why in my last video I mentioned how important white blood cells are, and this is also a reason. Because neutrophil, eosinophil, basophil, um, are also important. So neutrophil, we're gonna start from the top. These are first in line. These are like, get out there, go, go, go. These are the brave ones. So how am I gonna remember that neutrophils are the first ones? We can think neutral. They're neutral. They just keep going. Like, I don't know, neutral. They don't care. They're neutral about living or dying. Like, they're just there to fight. And then eosinophil. They regulate inflammatory response. And then mast cells and basophils also regulate inflammatory response, but they also release histamine. I don't know. So histamine causes contraction to the muscles and dilation of capillaries. So histamine just helps with the process. So mace and basophil work together, releases histamine. So think of it like the baseline starts closing things up. It works at the base. The maces, think of them like archers, like they're at the base, but they're doing different things. And then eosinophil, like the EOS chapstick, um, hydrates your lips to regulate that response to the dryness. So then we got macrophages, macrophages. I don't know what the hell that is. Macrophages. I'm saying that so wrong. Like, it's just not good. But I know these eat. Macrophags, bro. I'm saying it so wrong. Macrophag. They engulf. So that just means they eat. Like, this is how things start. Then dendritic, dendritic. This is so bad, guys. How do I say these words? Dendritic. How to say? Dendritic. Bro. Dendritic activates naive T cells. So this means like. So okay, remember this is where the adaptive starts. Macrophags. Dendritics activate naive T cells, so they don't know anything yet. They're naive. And then we got natural killer cells. They aren't phagocytes because they actually kill the infected cells. Yeah, so they're kind of evil, but they're needed. Then we got adaptive immunity. So we got T cells and B cells. These are kind of what is going on here. T cells and B cells. We got memory and helper T cells. These come fight. Once this all this shit happens. Then we got cytotoxic T cells. These kill, like they're evil. We got suppressor T cells. These stop immune cells. So like suppress. Then we got memory B cells and then some turns into plasma cells. A lot of good things happening. I did try to simplify this because I need to stop like going into so much detail. I feel like it's less efficient. I fear. Okay, and then we got lymphatic system. Oh yeah, sorry. So the lymphatic system, I really simplified this. It protects your body from infection and maintains fluid balance. So it's important to know what's in our lymphatic system. We got lymph. Lymph is a watery fluid that has things inside that transports our cells around. We got lymphatic vessels, which are very similar to blood vessels, but these carry lymph. Oh, I have to in my eye. Oh, the flip, bro. Flip. Well, actually, I'm tired, Grandpa. I'm so tired. Okay. Is this eat? Yeah. Yeah. Yeah, there is something in my eye, but we ball. After the vessels, we're gonna go to the lymph nodes. Lymph nodes and lymph work together, like they go hand in hand. Lymph nodes are veins that are found all throughout our body. There's hundreds and hundreds of them, mainly found in our armpits, our groin, or I don't even know what else, but weird places like that. They're veins that filter lymph and trap pathogens. So they filter lymph and trap pathogens. So this and that, right? What organs work? Okay, it did pause my video, which is really rude. I'm really digging this hairstyle. I look like a character from um Borax. I look like a tree. I mean, I feel like a tree. Can you even see that? I feel like that. God. Anyways. Anyways. Oh yeah, we're on what organ? So we have okay, the thymus. I can't lie, like the thymus. I forgot where this is. So see, like random things just start popping up. This is what I'm saying. But it's in our chest between our lungs, and it's a gland where T cells mature. So actually, I didn't know that. So yeah, it's in our between our lungs, and that's where T cells mature. And then organs are because that's a gland, right? Like we have our spleen. Our spleen filters our blood, which and also produces lymphocytes. Very important. Our bone marrow produces lymphocytes as well. We have tonsils and adenoids. One sec. Oh, these are in our mouth. Okay, behind our nose, above the roof of our mouth. Oh, it shrinks as we age. I don't like that information. Shrinks as we age, that means that more germs are able to come in our mouth. Because our mouth is always it's always gonna be open during the day. That sucks. That really sucks. So this protects from pathogens entering our mouth and nose. Okay, that is really all I wrote for my notes for the immune system. So my idea, I did already go through the quiz, but I like, oh, what's going on here? We don't have to do all that. We don't have to do all that. Okay, stop, bruh. So we're gonna go through this quiz. I did already go through it, but I like to go through it again and like explain because I did get one wrong. I want to go through and explain because like when I get something wrong, but it's okay. Where do T cells mature? So let's go through our answers. We have the thymus, thalamus, tegmentum, and a thyroid. So if I was taking this test, I would break it down between the thymus and thyroid, just because like these two sound familiar. But I know that our thyroid, I'm allowed to do this. Oh, you can't even see it. Our thyroid location is in our neck. Where's our thymus location? Upper chest. We talked about T cells being produced in our chest between our lungs. And what was that called? Thymus. So I would have chosen thymus. So this is important here. T cells mature in the thymus and are involved in cell-mediated immunity. The initial activation of T cells occur when they encounter the specific antigen. Antigens are bad. 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 Oh my gosh. On the surface of an antigen-presenting cell. APC. Okay. Blank period. I like that I can just be in the middle. What structures are made by the body's white blood cells that fight bacterial infection? So what structures are made by white blood cells that fight bacterial infection? So remember, we listed off things that fight bacteria. So we got antibodies, antibiotics, vaccine, and red blood cells. So if I was taking this test, I would X out red blood cells because they don't fight bacterial infection, and they're just not made. Actually, okay, back up. They're not a structure made by a body's white blood cells. Vaccines, no, that's not made by the body. Antibiotic, not made by the body. See, I would have been between antibiotics and antibodies because just whatever. Then I would think I would say, antibiotics. That's not made by the body, right? That's you get that at the pharmacy. So we would do antibodies. Let's read it here. Antibiotics, which we said, which would have been our other choice. Okay, I don't know what the hell is. Okay, choice B, fight bacteria, but the body does not make them naturally. It doesn't make them naturally. It's asking what the body makes naturally. White blood cells, not red blood cells, are the blood cells produced that fight the bacteria. So yeah, like I said, like red blood cells do fight bacteria, but they don't. They're not white. Vaccines, choice C, are given to create antibodies. So yeah, we all know vaccines are from the doctor. Which of the following is not a component of the non-specific immune mechanism? So what's not a component? So we're going to be looking for things that are components of non-specific immune mechanisms. You know what? I got this one wrong. Because which is a component of the non-specific. See, this is like, I'm thinking non-specific immune system mechanism. What is tripping me up about this one is the non-specific part. Like, non-specific. Okay, okay. So let's just go through it. Skin. See, it makes sense when I read these. Skin is a non-specific immune mechanism. I personally think this is talking about adaptive immunity. That's more specific because it adapts to things, adapts to it. So, like, something specific. But skin, I chose skin originally, which was wrong because actually it's non-specific. Whoops. But now I know it would be skin because it's non-specific, like it would help either way. Inflammatory response is non-specific. So I'm thinking of what I wrote, the list for adaptive and immune and innate. So neutrophil is innate. So it's antibodies. Mm. Don't touch her. Don't touch her. So antibodies are a component of the specific immune response, unlike the components of the non-specific. See, this is what I'm talking about. Like, why do you have to write non-specific? But you could have just written like, you could have just written it, bro. Okay. So the non-specific immune mechanism antibodies, which That was rude. Okay, I get it now. Like, honestly. And then, what is the name for any substance that stimulates the production of antibodies? Collagen? No. Hemoglobin? No. Lymph? Okay, it's an antigen. Remember, antigens are bad, and so we need antigen to produce our antibodies. Lymph transports things. An antigen is any substance perceived by the immune system as dangerous. Like, okay, like an antigen means foreign substance. Collagen is one of the components of bone, tendon, and cartilage. It's a spongy protein that can be churned into gelatin by boiling. Hemoglobin is the part of the red blood cells that carries oxygen. In order for the blood to carry oxygen to the cells of the body, there has to be sufficient amount of hemoglobin. Lymph is a near transparent fluid that performs a number of functions, removes bacteria, replaces lymphocytes, and moves fat away from small intestines. Lymph contains white blood cells. Eosinophil, basophil, neutrophils are all examples of what? White blood cells, also called I don't know, are cells of the immune system involved in protecting the body against foreign invaders and infectious diseases. There are several types of white blood cells, including Alright, thank you for watching. I'm gonna keep studying, but I think that's good.